Alright guys, so what we're going to be going over today is how to find the slope of a line. Alright, let's start off with what a slope is. Slope is defined as the rate of change. Alright, so the rate of change is the rise over the run. What rise means is going up and down. So when you go up and down on the y-axis, so that means the change in y. Alright, when you're going up and down, your vertical change. Now your run, alright, you run left and right, okay, it's called your change in x. Right, or your horizontal change. So, rise over run, or change in y over change in x. Now, how do you find slope with 2 points? Well, if they give you the graph itself, alright, it's kind of easy to do, but if they give you 2 points, you use a formula. It's called y2. Let's zoom in on this. Alright, the formula is y2 minus y1 over x2 minus x1. That's what you use when you're trying to find the slope given 2 points. But if it's on a graph itself, it's kind of easy to find the slope. So here we have a line, okay? We have point A, we have point B. You could pick any 2 points, it doesn't really matter on this line. You could pick this point, you could pick this point, you could pick this point. Any 2 points on the line. The easiest way to tell where a point is just figure out where a definable point is. Like right here is a definable point because you can definitely tell where your y and your x is. But we're just going to say A and B. Okay, so starting from A, we got to do our change in y, or our vertical change. So let's look at the vertical change. So how far up do we have to go? Well, we're trying to get on the same level as B. So B is right about here. Okay, so this is the same level as B. So we will go up 1, 2, 3, and 4. So remember we went 1, 2, 3, and 4. So our change in y is 4. Alright, 4 over. Okay, now let's see our run. How far over do we go? Well, we go over 1, 2, 3, 4, 5, 6, 7, 8. So we went over 4, we went up 4 over 8. Now 4 over 8 can be reduced. If you divide both the top and the bottom by 4, alright, you end up getting 1/2. So technically our rate of change, or our slope, is 1/2 in this case. Okay? That's how you find slope given the line. Now given 2 points, okay, given 2 points, you had to do, alright, the formula. y2 minus y1 over x2 minus x1. Okay, y2 minus y1, x2 minus x1. Now how you can tell, okay, since this is an x, this is a y, this is an x, and this is a y, this is our first x, okay, so this is called x1. This is our first y, so this is y1. This is our second x, which is x2. This is our second y, which is y2. So when we plug into this formula, we're going to get -3. So -3 minus y1, which is 7, all over x2, which is 4, minus x1, which is 8. So, negative 3 minus 7 is negative 10. 4 minus 8 is negative 4. Okay. Both of these can be reduced by negative 2. And we end up getting 5 over 2. So, our rate of change is 5 over 2. That means we'd go up 5 over 2 to get from one point to another. That's our slope. Okay. So what I want you to do is pause the video. I want you to try this problem here. And then I want you to try finding the slope off of this problem here. Okay, so once again, x1, y1, x2, y2. Alright, so it's y2, which is 6, minus y1, which is 4, all over x2, which is 5, minus x1, which is 3. You get 2 over 2. Alright, 2 over 2, which reduces down to 1. Your rate of change is 1, or technically 1 over 1. So you would go up 1 over 1. Alright. Right here, we have a point. You can see it right here. We have another point, which is right here. So now we can define the slope from this one. So, right here. So how far down? Okay, so we're either going to be going up or down. Well, since this point is lower than this point, okay, we're always going left or right. Since this point is since this point here is lower than this point, we actually have to go down. So we have a negative rise. Okay, that means we're going to be going down 1, 2, 3, 4. So we have negative 4. Okay. So we went down 1, 2, 3, 4, and we went over 1. So it's negative 4 over 1, which equals just negative 4. Now onto those special lines we keep talking about. We keep talking about special lines because it's important to remember what a special line is. It's our horizontal and vertical lines. Alright? Now, let me show you what it looks like when we actually try to use the slope formula to find the slope for vertical and horizontal lines. So, this one is going to be for a vertical line. Now, let me show you what it means to be vertical. Okay, so this is x1, y1, x2, y2, okay? So 0, minus 4, alright? Negative 5, minus, okay? Another negative 5, alright? So we get two negatives, 1, 2 negatives. Now since we have two negatives, they become a positive. So right on top we've got 0 minus 4, which is negative 4. Negative 5 plus 5, which is 0. Now, I don't know if you remember this from other math classes, but whenever you have a 0 on the bottom of a fraction, what we call this is undefined. Alright? Negative 4 divided by 0, essentially what it's saying is how many groups of 0 can you take out of negative 4? It's an unlimited number amount. So technically it's really undefined on what the answer is going to be. So, this is why we know it is a vertical line because it's going to be undefined. So if I were to actually graph this, okay, if I were to actually graph this, we know this is a vertical line, and we know that when we have vertical lines, all we have to do is find the x value, okay, so find the x value. Since we're repeating the x value every time, -5 and -5, we know we need to find -5 on the x-axis. So let's find the -5 on the x-axis. Ready? 1, 2, 3, 4, 5. There's technically a vertical line where x equals -5. Okay, so this is a vertical line. Okay, it has no slope. It's undefined. All right, it's undefined. Now let's go on to a horizontal slope. Now, since a vertical slope has no slope, all right, horizontal slope, I'm going to show you what it looks like. So we've got I'm sorry guys, hold on. Something freaky going on outside, sorry. Alright, so we've got these. Okay, so we've got our x1, our y1, our x2, our y2. Okay. So once again, we're going to do the slope formula. 2 minus 2, alright, over 1 minus 0. Well, 2 minus 2 is 0. 1 minus 0 is 1. So, now we have 0 divided by 1. How many groups of 1 can we take from 0? Well, that's 0. Okay? So, this is what is a horizontal slope. Alright, horizontal. That means that there is a 0 slope. There's still slope, it's just 0, meaning you have no rise and you have no run. Or actually, so you just essentially have a straight line. Now, since you notice, once again, if we're going to graph this, horizontal lines, okay, always have the same y number. Doesn't matter where you're at, it's always going to have the same y number. So we're going to find where 2 is at. 2 is at right here. Okay? We're going to draw a horizontal line where y is 2. Okay? Y is 2 right there. So we drew a horizontal line. Okay. Now, on to the next part. Slope angle. Alright, this is just a little bit the bigger the slope, alright, meaning the bigger the number is, whether it be positive or negative, the steeper the line. So, slope angle, what it pretty much trying to say is that the bigger the slope, the steeper the line. Think of a hill. Okay, so the more the hill is inclined, so if you have like a really, if you have like a hill that looks like that, it's not very steep. But if you got a hill looking like that, alright, that means that it's extremely steep. So things like, alright, 1/4 or 1/8, alright, these slopes are kind of looking like something like this. But when you think at things like, I don't know, 5, alright, 5/1, 10 over 1. Stuff like this makes a steep slope, okay? The closer you get to undefined, alright, meaning the straight up and down line, the vertical lines, the more steep the object will be. So, if you had something like this, you're going to have a, let me show you, alright? So, let's use 1/4. So I'm going to pick 1 point. Let's say we pick that point, 1/4, alright? I would go up 1 over 1, 2, 3, 4. Notice how not steep that is, alright? It's a very slight incline. Now let's try doing something like 5 over 1 from the same point. Ready? 1, 2, 3, 4, 5 over 1. So this is 5 over 1, and this is 1 over 4. Notice the drastic change in steepness. This is kind of like a baby slope. This thing, if you tried to ski on, you would kind of like go pretty much skiing to your death because you'd be going way too fast to really stop. Alright, so those are honestly the ideas behind slope angle. So if you have like a 1/4 slope, if you have a small slope and you notice your incline is really big, then you know that you did something wrong. Really, this property is just to help you guys out, trying to think logically about whether or not your answer is correct. Now, let's move on to the last part, which are parallel and perpendicular lines. Okay. Parallel and perpendicular lines. Okay. Alright, so parallel lines are two non-vertical lines. Are parallel if they have the same, that should be slope and different y-intercepts. Okay, so same slope, different y-intercepts. Remember, y-intercept means where it crosses the y-axis. Where it crosses the y-axis. For example, if you had y equals 3x plus 4 and y equals 3x minus 5, these lines would be parallel. The reason is our slope is the same. Okay, so both slope is a 3, but the y-intercept is different. This is a 4 and this is a -5, which means you're going to have two lines that never touch. Alright, they're going to go run parallel to each other. That's what parallel means, is two lines that never touch. So notice they have the same slope, different y-intercepts. Now sometimes you can't tell what that is, so let's make up a problem in which you can't really tell whether they're parallel or not. Let's see if we can test it out. Let's say we had 6x minus 5y, alright, equals, I don't know, it's 18. Alright, actually not 18, let's go with, apologize. Let's go with 20. Alright, nice even number. And we're trying to see if it's parallel to, I don't know, let's go with 12x, negative 12x plus 10y, and it equals, let's go with 15. Okay. Alright. Now you have two different lines here. We don't know whether or not they have the same slope or not. Okay, so this is how we test it out. In this area, you obviously, you wouldn't even have it in the y equals format where we can actually tell what the slope is. So this is what we're going to do. We're going to first, step one would be to actually get into the slope-intercept form, meaning the y equals format. So we get, let's first take 6x minus 5y and set equal to 20. Let's change this. First, let's get rid of the 6x. We subtract 6x from both sides. Okay, so we subtract 6x from both sides. This becomes negative 5y equals 20 minus 6x. Alright? Next step. Divide by negative 5. Divide by negative 5. Divide by negative 5. Okay, so we get y equals, okay, this turns into a negative 4. This turns into a positive 6 over 5x. Alright, so we're going to look to see if this second line over here makes a 6 over 5x, but a different y-intercept, meaning different than negative 4. So let's try it. Negative 12x plus 10y equals 15. So let's add 12 to both sides. So you got 10y equals 12x plus 15. Divide by 10. Divide by 10. Divide by 10. Y equals, alright, 12 over 10x plus 15 over 10. Now, going trained eye, these look different, right? But we haven't done something. We haven't reduced. Okay, we haven't reduced. So first we got to reduce. 12 over 10 can be reduced by 2. So this becomes y equals 6 over 5x, alright, because we could reduce both by 2. And we can reduce these by 5 plus 3 over 2. Notice, I have two different problems, okay? This one is 6 over 5, this one is 6 over 5, so they have the same slope, but different y-intercepts, meaning where they cross the y-axis. So these two lines would be parallel. Alright. Okay, so now let's go on to perpendicular. Two non-vertical lines are perpendicular if the product of their slope is negative 1. Okay. What do I mean by the product of their slope is negative 1? Well, if you have negative 2 over 3 and 3 over 2, okay, if you multiply them together, okay, so if we had negative 2 over 3 multiplied by 3 over 2, okay, notice what happens. So when we multiply fractions, we multiply straight across. Negative 2 times 3 is negative 6. 3 times 2 is 6. Negative 6 divided by 6 equals negative 1. Notice how when we multiplied their slopes together, we ended up with negative 1. The reason is because the slope of a perpendicular line is the opposite reciprocal. Now, opposite means to change a sign. So you change it from positive to negative or negative to positive. And reciprocal means to flip a fraction. So if you notice, from here to here, the opposite, meaning change the sign, would become positive. So a number would go from negative to positive. And you would flip the fraction upside down. So you take 2 over 3 flipped upside down, you get 3 over 2. That's how you know that you have made an actual perpendicular slope. Okay? So let's actually test that out. Okay? Once again, if you had something like, I don't know, 2x minus 3, actually let's go 2x minus 5y equals 10, and negative 5x minus 5y equals, 2y equals 8. Okay. So let's look at this. Alright, so first let's do the first one. 2x minus 5y equals 10. First, subtract the 2x from both sides. So you get negative 5y equals negative 2x plus 10 divided by negative 5, divided by negative 5, divided by negative 5. Okay. So these cancel out. This becomes 2 over 5, and this becomes negative 2. So y equals 2 over 5. 2 negatives makes a positive. Minus 2. Okay, so that's what our first line looks like. Now let's compare the second line. Negative 5x minus 2y equals 8. First step is to add 5x to both sides. So we get negative 2y equals 5x plus 8 divided by negative 2, divided by negative 2, divided by negative 2. We get y equals negative 5 over 2x minus 4. Now, do we have opposite reciprocals here? So if you look here, we got 2 over 5. Over here we got negative 5 over 2. So the opposite, meaning opposite sign, would be negative of this. So this does have a negative sign. The reciprocal would be 5 over 2 instead of 2 over 5. So this is 5 over 2. So yes, these two things are perpendicular lines. So I want you guys to try these two by yourself. See if you can do these two and figure out whether or not they're parallel lines. Alright, so let's do the first one. So first step is to actually get the actually this is supposed to, I think this is supposed to be a y, and there's supposed to be a y behind this one. Do apologize, that's where those two things are. I'll fix it in the notes. They should be fixed by the time you actually get the notes, so just know that that's what we're trying to do. Alright, so we get the first one, 3x plus 7y equals 4. Okay, first step, as always, is to get rid of the x first. Subtract 3x, subtract 3x. 7y equals negative 3x plus 4. Next step, divide by 7, divide by 7, divide by 7. So we get y equals negative 3 over 7x plus 4 over 7. Okay, so let's try the second one. 6x plus 14y equals 7. Subtract 6x, subtract 6x. 14y equals negative 6x plus 7. Divide by 14, divide by 14, divide by 14. This ends up being y equals, this can reduce, negative 3 over 7x plus 1/2. Alright, so notice same slopes, different y-intercepts, so these would be parallel. Okay, parallel. This problem, alright, solve plus x, you get 3y equals x plus 2, divided by 3, divided by 3, divided by 3, you get y equals 1/3 x plus 2/3. The other one, 2x plus 6y equals 5 minus 2x minus 2x. 6y equals negative 2x plus 5 divided by 6 divided by 6 divided by 6. Okay. Alright, once again I finish this off. I divided by 6 everywhere. Okay. So this actually is y equals negative 1 over 3x plus 5 over 6. Notice we reduced this down by 2 on each. So now I have a negative 1/3 here, and I have a positive 1/3 here. Now, does this mean that they are perpendicular? Well, let's see. First, did we get the opposite part right? Well, there's no negative here, and there's negative here, so the opposite's correct. Is the reciprocal correct? Well, this is 1/3. Well, this is also 1/3. So these aren't perpendicular, and they're not parallel. So, not perpendicular or parallel. Okay. Now I'm going to add an extra sheet. Now this is going to be just a little bit longer. I do apologize, guys. I know I said I was going to do a 30-minute snippet, but I think this is also something that you're going to need to know. Is how to find a perpendicular line, or in parallel line. So sometimes they're going to give you something like this, like you have find a parallel line. Alright, find a parallel line that goes through find a parallel line that goes through 2x, or let's say y equals 2x plus 5, and find a parallel line that is, okay, so it's parallel to this and goes through 0.56. Okay. The easiest way to solve this is first know what a parallel line is. Parallel line is a 2. Alright, so 2 is your parallel line, so your slope would be 2. Alright, then you have 5/6 is your point that we want to go through. So if you see that, this is what you do. You take your slope and you put it in. Actually, we're just going to stop here. I will teach this on a different lesson.